RD Sharma solution class 12 chapter 5 Algebra of Matrices exercise is 5.3. If A equals diag, that is diagonals of ABC, show that A raised n equals diagonal of A raised n, B raised n, C raised n for all positive integer n. So whenever we encounter this kind of question, we have to do it using the principle of mathematical induction. So how do we do this? We'll apply the method which we have already seen in previous questions. The first step is we need to prove it that for n equals 1 this is true. If we place n equals 1, it has to be equal to the thing which is given, which is A equals diag ABC. What is diag ABC? Let me write diag AN, BN, CN. This is AN, BN, CN only in the diagonal. Other values are going to be 0. So A raised 1 means n, replace n by 1. So what do you get? You get here, this all other values are 0. So this is A, B, C. Here 0, 0, 0, 0, 0 like this. So this is nothing but A raised 1. This is diagonal of A, B, C. So for n equals 1, this is proved. Now we assume the second step always in the principle of mathematical induction is we assume that this is true for all k, any k. And we need to prove it that if it is equal for k, okay for k, it is also true for k plus 1. So let me write A raised k. So wherever we have n, just replace it by k. You can replace it by m also, it depends on you. Normally in principle of mathematical induction we use k. Now here, the third step is if it is true for ak and if it is true for ak plus 1, then it is true for every other number. So ak plus 1, that is wherever you are getting this k, you need to get k plus 1. That is, it is true for k, that is k plus 1 and the k plus 2 like this. So it will be true for every other number. So A raised k into A raised 1. A raised k plus 1 can be written like this. So A raised k is already given, means already we have written. Now I am writing A here, A raised 1. So I am writing this A00, 0B0 and 00C. Okay. So now we have to multiply these. The first one is A raised k, second one is A. So wherever you are seeing k, if it comes out to be k plus 1, then it is true for A raised k plus 1 also. Okay, let us multiply. You know how to do the matrix multiplication: first row, first column, first row, second column, first row, third column. Similarly, we do it with the second row and third row. Same thing. So A raised k and into A are the 0. Then second one also all are zeros because A, third one also AK0 is 0, 0, 0, C. Now coming to the second row, 0, 0 and A is 0, BK 0, 0, 0, so 0. Now second row, second column, 0, 0, BK, B is BK into B. B raised K into B. Now 0 into 0 is 0 again. So what do you get? 0. Now third one. Third row and first column, 0, 0, 0, 0, C into 0 is 0. Now third row, second column, so 0, 0, 0, B in 0, C into 0, 0. And then we have the third row and the last column. So 0, 0, 0, 0, 0, 0, C into C, C raised K into C. So what is A raised K into A? It is A raised K plus 1. But how can we write this? See. A raised k plus 1. We can write B raised k and B raised 1 is B raised k plus 1. C raised k and C raised 1 is C raised k plus 1. So what is this? This is what we wanted. This is A raised k plus 1. Hence, from the principle of mathematical induction, it is proved for all positive integer n. A matrix X has A plus B rows and A plus 2 columns, while matrix Y has B plus 1 rows and A plus 3 columns. Both matrices XY and YX exist. Find A and B. Can you say XY and YX are of the same type? Are they equal? So first matrix. Now you need to know that the column of the first matrix has to be equal to the row of second matrix. That is, if this is the row and columns are I'm writing, A plus B is the rows and A plus 2 is the column of the first matrix, which is your X matrix. Now coming to the Y matrix, we have the row number as B plus 1 and the column number is A plus 3. So B plus 1 is row, A plus 3 is column. Now, as I said, the column of the first matrix has to be equal to the row of the second matrix, then only multiplication is possible, otherwise it is not. In any kind of multiplication. Okay, if xy is existing, a plus 2 has to be equal to b plus 1. Xy is existing. That is, a plus 2 is equal to b plus 1. This is our first equation. Now, yx is also existing. That is, when you multiply y and x, the column of y should be equal to the row of x. That is, a plus 3 has to be equal to a plus b. First one was a plus 2 equals b plus 1 for x into y. But y into x, these two has to be equal. That is, a plus 3 has to be equal to a plus b. A plus b. And it's clearly seen from the second equation, b is 3 because a gets cancelled. Now a plus 2 equals b plus 1. So here you can write it as b minus a as 1. B minus a as 1. And this is a you can just cancel. B is directly, you can see b is 3 here. So b is equal to 3. Now when you put b is here, 3 minus a is equal to 1. So a is equal to 3 minus 1, that is 2. So a is 2 here, not 4. I'll just correct it. So what do we get? That a is 3 minus 1, 2, b is 3. So we got the value of a and b. Now there are certain other questions also being asked. Find a and b, we have already found out. Can you say x and yx are of the same type? They are not of the same type, because I'll just give you an example. Because a and b we know. Now let us write, because we have to see the orders. X is 5 by 2, because a plus b is 5 and a plus 2 is 4. Y is what? B plus 1, that is 4. And a plus 3, that is 2 plus the 5. Now the orders are not same. The orders are not same. Give examples of matrices A and B such that AB is not equal to BA. A and B such that AB equal to 0 or null matrix, but A should not be and B should not be equal to null matrix. Third one, A and B such that AB equals null matrix, but BA not equal to 0. Fourth one is ABC such that AB and AC are equal, but B not equal to C, and A should not be equal to the null matrix. Now all this comes with practice. You cannot directly write these matrix. No one can write these matrix. This just come from practice. When you do 50-60 questions like this, then you know how to do this. So let me give you an answer here. A is this matrix, B is this matrix. This matrix, once you multiply it, you can take any matrix. Don't use any, this matrix. You can use any matrix 2 by 2, and you see A and B and A will not come equal because they are not commutative. Sometimes it may come equal, sometimes. But most of the time, means 99.9% of time, AB will never be equal to BA. Second is A and B. Now, when A and B you want to be 0, then how do you do it? See, if you are making 2 by 2 matrix, then you put 2 here. That is at the first row and second column, cross intersection. For the B, you take the first row, first column. Put some value there. Okay. We have placed a 2 value here. That is first row and second column. In the second one, in the first row, first column, we have placed certain value. You can write any value. We have just put 2, 1, you can write 5 or 10, whichever. Because ultimately it is going to give you 0. And we just have to say that they are not also 0. So we have put some 2 and 1 value. Third one, BA should not be equal to 0. AB should be 0. Same thing, I told you how you choose A and B so that it becomes 0. Okay. But when you do B into A, but the formation will change and it will not come to 0. A and B, we have specifically given certain value. We have placed certain value. Other values we have given 0. So AB is 0. But as I said, AB and BA are not, AB is not commutative. AB into BA, AB into A into B into B into A is not equal. Okay. Coming to the fourth one, A, B, C such that AB is equal to AC, but B should not be equal to C and A should not be equal to 0. Null matrix. So you have this A, B, C. Now A is this, B is this, and C is this. Now you see, A we have kept like that. That is the first row, first column. The B and C, the second row and the last column. That is second row and the second column. We have placed certain value. 1 here, 2 here. just to make it that B should not be equal to C because it is given in the question. Okay, but since we have made B and C such that it will always give you A into B or A into C as 0, because B and C we have not made it equal. One place we have put 1 and one other place we have put 2. So this is how it goes. Let A and B be the square matrix of order, same order. Does A plus B whole square equals A square plus 2AB plus B square hold? If not, why? Now, very simple property. Just assume and know and keep in your mind that when you do A plus B whole square normal values, A square plus B square plus 2AB, because AB plus AB will come 2 times and AB and BA are equal. But when you do the matrix multiplication, AB and BA are not equal because the matrix multiplication is not commutative. So when we do A plus B whole square, just multiply each and every value. A into A, then A dot B, then B dot C, then B dot B. So A dot A you can always write as A square. B dot B you can always write it as B square. But AB and BA, they are not same because they don't follow the commutative property. So this is not equal. A plus B whole square is not equal to A square plus B square plus 2AB. This is very true with any matrix because commutative property doesn't hold for multiplication. There are certain questions coming which are like that, like this one. See, the first one, second one, and even the third one, they have the same logic and reasoning that the commutative property doesn't hold. A plus B whole square already we have seen, just multiply A plus B and A plus B separately. And the second one I'm showing you now, A minus B whole square, same thing you have to do. I'll just give you a hint of the second one. A minus B whole square, that is A minus B into A minus B you have to do. Now see, A into A is A square. Now A into B minus A into B, and then minus BA, and then B into B is B square plus B square. Now A, B, B, A are not equal, so you cannot cancel them. Okay, so it will be A square plus B square minus AB minus B. You cannot write like A square plus B square minus 2AB. Coming to the third one. Third one is A plus B into A minus B. Just multiply it. This is not also equal because again the same thing that the commutative property doesn't hold. Now A plus B into A plus B, because A plus B into A minus B we are doing. A into A, then A minus B is minus AB, and B into A is plus BA, then you have B into B is minus B square. Now essentially you want to cancel these two, but you won't be able to do it because AB and B are not equal. So you just have to write A minus B whole square is nothing but A square plus A square minus AB plus BA minus B square. That is the final answer. This is a separate entity. It is not what we have done already. 3 shopkeepers ABC go to the store to buy stationery. A purchases 12 dozen notebooks, 5 dozen pens and 6 dozen pencils. B purchases 10 dozen notebooks, 6 dozen pens and 7 dozen pencils. C purchases 11 dozen notebooks, 13 dozen pens and 8 dozen pencils. A notebook costs 40 paisa, a pen costs 1.25 rupees and pencil costs 35 paisa. Use matrix multiplication to calculate each individual's bill. First we have to formulate the matrix and then we have to see whether we can multiply the matrix. Thus we have to make the two matrix such that it is multipliable. Okay, so just make it. Just see what is given in the question. The question is, we have 3 shopkeepers. So without any notice, just write whatever is coming into your mind. A, B, C, 3 shopkeepers. So I'm just writing A, B and C. Now every shopkeeper, there are 3 items being given for every, and their numbers also given. So A purchases 12 dozen. So I'm writing notebook, then the pens, and then we have pencils. Okay. So PN is for pen and PL for pencil. Now A's notebook, how much is there? It is already given 12. Now A's pen is 5 dozen. A's pencil is 6 dozen. Now this is B. So B has 10 notebooks. It has 6 pen and 7 pencils. C coming to 11 dozen notebook, 13 dozen pens and 8 dozen pencil. Okay. Now we just wrote what we have learned in the question. But actually it is a matrix. Matrix is nothing but the arrangement of numbers only. Okay. Now our notebook costs 40 paisa. Now the cost is in 40 paisa. So, and the question is 12 dozen. So just multiply each. The cost of dozen we are taking because the every value is given in the dozen. So 40 into 12, 1.25 into 12 and 35 into 12 you have to do. So when we multiply 40 paisa with 12 rupees, we'll get 4.80. 40 paisa into 12 dozen. Then 12 amount with 1.25. Then 12 into 35, you get 4.20. So this first matrix is already being made according to the arrangement. But the multiplication should be such that it is multipliable. That is, this matrix is 3 by 3 matrix. And the column number of the first matrix has to be equal to the row number of the second matrix. Then only it is multipliable. So we are writing this matrix. The second matrix can only be 3 into something. Okay. So 3 into something, 3 into 1, because it is given 40 paisa. We can convert it for 4.8 is the cost of first element, this notebook. 15 is pencil, and this pencil pen is for 15, pencil is 4.2. So 3 by 3 and 3 by 1, when you multiply this, you will get 3 into 1. This is the final one. So you get 3 values, and that is what we wanted. Okay. So let us see here. First, second, 3 values has to come. So I'll show you to you here because it will take some time. I have given you the idea now. Okay. So this we multiply 12 into 4.80 plus 5 into 15 plus 6 into 4.20. That will be the first entry. Second is 10 into 4.8 plus 6 into 15 plus 7 into 4.20. That will be the second entry. Then third one is 11 into 4.8 plus 13 into 15 plus 8 into 4.20. That will be the third entry. Now all these 3 entries we compute, and whatever you get, the first one is A, second is B, third is C. These are the bills. These are the amount 157.80, 167.40 and 281.40. The cooperative stores of particular school has 10 dozen physics book, 8 dozen chemistry book and 5 dozen mathematics book. Their selling prices are like this. Find the total amount the store will receive from selling all the items. So you have to make matrix first. And those matrices which are multipliable. That is, the column of the first matrix has to be equal to the row of the second matrix. Okay, the first thing is given is 10, 8 and 5 dozen. Now since 10 dozen physics book is there, so there we'll make a row matrix and we have to multiply it by 12. Every value has to be multiplied by 12. I'm writing it for books. So 10, I'm making a row matrix, 10 dozen, so 10 into 12, what is that? 120. Okay, 8 dozen, 8 into 12, what will it be? 96. Then 5 into 12, what it will be? 60. So this is our matrix. You can call it as B or whichever you want, or call it as X. Now the second matrix is the pricing. Since the pricing is already given in rupees, we don't have to change it. So the first matrix is 1 into 3. First row, 3 column. Now second matrix has to be 3 into something. Then only we can multiply it. See, if you do this 120, 96, 60, then this is 3 by 1. So the other has to be a row matrix. Essentially the answer is going to come same. Okay. But still there has to be a way multiplicity or multipliability of the matrix has to be considered whenever we are solving this kind of question. Okay. So now the second matrix will be simply, we'll make a column matrix and it will be 8.3 and 3.45 and 4.5. These will be the entries in the column. Just write it in the column. Okay, now this is how, because 1 into 3 and this is 3 into 3 rows and 1 column. Now it is multipliable only, and the result has to come only one value. Find the total amount. So the answer is coming also. This is how we formulate. The answer will be 1 into 3 and 3 into 1. These two cancels, 1 into 1. There will be only one value. So B into P we have to do. So I'll just show you here. I'll give you the logic. Now how you have to do, you just have to multiply these two matrices. 120 into 8.3, 96 into 3.4 and 60 into 4.5. Just add them. And the final value you are going to get is 1597.20. This is the requirement amount. In a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways. Telephone, house calls and letters. The cost per contact in paise is given matrix A cost per contact. These are in paisa. So this is all for publicity, telephonically, house call or being sending a letter. Now this is first matrix. This is simply given as the column matrix. The second matrix is the number of contacts of each type of in the two cities X and Y is given in the matrix B. Telephone, house, letter for X and Y cities. Find the total amount spent by a group in the two cities X and Y. So the answer should come only two values. So a matrix should be only two values. So just see the order, then we will multiply. Now essentially we have to multiply these two matrices, nothing else. Okay. So we have 3 rows and first column here. Here 3 row, 1 column. Here we have how many rows and column? 2 rows and 3 columns. So we cannot multiply A with B. We have to multiply B with A. A and B is not possible because the column of the first matrix is not equal to the row of the second matrix. But if we do B cross A, this is 2 cross 3, this is 3 cross 1, and 3 cross 3 will cancel, and 2 cross 1, that is 2 values will come. That is what is wanted in the question also. Total amount spent by the groups in the two series X and Y. Okay, let us take these two matrices and multiply, just multiply. Okay, so this is 1,000, 500, 5,000, 3,000, 1,000 and 10,000. Multiply this with this second matrix, which is A, 40, 40, 100 and 50. Please remember these are in paise. So let it be in paise. When we reach the answer, we will convert it into rupees. Now multiply these two. Okay, let me show you how we have multiplied. See, 1000 into 40, 500 into 100 and 5000 into 50. Just add them. Now the second row and the first column. Second row and the first column. 3000 into 40 plus 1000 into 100 plus 50 into 10,000. Just add them, you get 3,40,000 and 7,20,000 in the X and Y. But this is in paise. This is in paisa. So you have to divide it by 100. Just divide it by 100 and you get the 3,400 rupees and 7,200 rupees. Okay, this is for X and this is for Y. A trust fund has 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide this 30,000 among the two types of bonds if the trust fund must obtain an annual total interest of 1,800 and 2,000 rupees. This is NCERT question. Okay. So how we are going to do it? First, we have to divide this 30,000 into two parts. So if 30,000 is there and one part we assume to be X, the other part will be what? 30,000 minus X. If the amount is given as 10, if you divide into two parts, one will be F, the other will be 10 minus 5, that is 5. Okay. So X and 30,000 minus X. These are the two parts. This is first matrix. Now there are 5% per year and 7% per year. This is the first matrix is first row, second column. The second matrix has to be made such that the row number has to be 2. Otherwise, multiplication will not be possible. So 2 rows, one is 5 by 100, the other is 7 by 100 because this is the interest rate being given. You can write 5 by 100 as 0.05. You can write 7 by 100 is 0.07. But that will restrict our multiplication. You will see just now. Okay, let me give you this idea. The X into, we have to multiply these two. X into 30,000 minus X and multiplied by 5%, so 5 by 100 and 7 by 100. Keep it as 5 by 100 and 7 by 100 because if we keep like this, you'll see what is the problem we face. This has to be equal to 1,800 one time and the other time it has to be equal to 2,000. First part I'm going to show you, 2,000 I'll just show you. Okay, X into 5 by 100, that is X into 500 plus 30,000 minus X into 0.07 or 7 by 100. This is equal to 1,800. This is what is given in the question. Let me just write this here. But multiplying with the point will be difficult here, or not difficult. No, it's not advisable. So just write it as 5 by 100 and 7 by 100, and take this 100 on the right hand side, or multiply everything by 100. So I'm removing it, keeping 100 here. So we get some amount on the right hand side, 5x. And this is 7 3s are 21, so 21 4 zeros and minus 7x equals 18 and then 4 zeros. Okay. So this 21 4 zeros and 18 4 zeros, take it on the left hand side, and 7x minus 7x will be 2x. So 2x will be equal to, what do you get? This is going to be 3 and 4 zeros. 21 minus 18 is 3. So you have 3 and 4 zeros. Okay. So this x will be equal to this 30,000 divided by 2, that is going to be 15,000. It is not 4 zeros, it is just 3 zeros. So I just have to change that. Or just guys please change that. So you get 30,000 minus 15,000. One is 15,000. So what will be the other amount? 30,000 minus 15,000 is what? So what do you get? 30,000 minus 15,000 is 15,000. So if the x amount is 15,000, the other will be 30,000 minus x, 30,000 minus 15,000, that is going to be 15,000. So one amount is this is how you have to divide. I hope you got the idea. So this is how the communication or this will work, because 1 0 is less, so this is just 50,000. Okay. Now this is the first part. The second part is same. You just have to equate not with 1800 but with 2000. Same thing remains. Everything remains the same. No change. Here you will get x as 5,000. Subtract it with 30,000. You will get 25,000. Okay. ABC is given. Verify that AB is equal to AC, though B is not equal to C and A is not equal to 0. So what you see in the question is essentially B is not equal to C. A is also not equal to null matrix. And A and B you have to multiply, and A and C you have to multiply. I will just show you, because this kind of questions we have done already. So just multiply these two and you will get the same matrix. That is AB and AC will give you 6, 7, 18, 21, the same. But since neither B and C are equal, nor A is equal to null matrix, these two will come same. This is, I leave it to you. This is simple multiplication. AB and AC you have to do. Okay. Let me show you again. AB and AC will give you the actual value, similar value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.